用过核燃料再处理，中期境外储存40年，减材机去釉布，无人岛核废料最终处置。宜兰人文基金会会诊。本会建议中期境外再处理储存40年流程图：一、核电厂用过核燃料池；二、陆上安全输送；三、国际安全海运；四、再处理厂作业流程；五、中期境外储存40年；六、1/4残余废弃物回运；七、残余废弃物无人岛最终处置。我国用过核燃料储存数量表，从民国67年第一座核电厂开始运转迄今，累计使用17128束用过核燃料。3座核电厂届满除役，预计将累计达23044束。核一、核二厂冷却池几经极大值扩充仍爆满，这使用过核燃料退无可退，无法完成岁修。继续运转将面临提早除役，无视台湾安全与永续的露天干式储存，又因盲主散存的安全疑虑，与核废料最终处置厂无着，核电厂恐成最终弃置厂。台电发言人林德福说，露天储存安全无虞，可延长30年、60年，甚至160年。
那么过去美国政府呢，给这个干式储存执照只有30年。那最近呢，美国这个官方政府在10月24号发布新的一个规定，在过去因为干式储存这边的措施认为在安全无虞之下，那也因应最终处置呢这边最后的一个地点的发展或者使用等等的期限在比较晚的阶段，所以官方政府呢就能够同意美国的干式储存厂可以从30年延长到60年的一个使用的这个执照，甚至于呢不排除呢未来可以使用到160年等等的这些新的一个规定。
现阶段因要用一个所谓的暂存的方式，干式储存的方式，就即马咱遐的地质条件，水土保持安全性，我们是存疑的，所以我们反对。另外一个更严重的问题，更加严重的问题，就是最终处置厂根本没有吹出来。你放你遐就要放40年哦，即马吹是讲40年，等于永久的同款。这新北市绝对不可能接受。
113亿处理1200束用过核燃料。目前台电决定进行核一、二厂用过核子燃料小规模国外再处理计划，期程为104年到127年，以化解目前冷却池爆满困境。总共要运出1200束核燃料棒。分4年完成，每年运300束，总计划经费共新台币113亿元。用过核燃料至再处理厂作业流程图。用过核燃料运抵再处理厂接收暂存后，经过切割、溶解、分离、纯化等再处理步骤后，其中铀与钚元素可回收再使用，制作 MOX 燃料。其他不可回收的分裂元素剥离固化，与燃料结构物高压减溶之后储存40年，最后再返运回国，需减溶为原体积的1/4。法国埃瑞法公司的拉哈格再处理厂简介。
Areva, La Hague site, while reducing the toxicity and volume of the final waste by reclaiming materials contained in spent nuclear fuel that can be recycled.
A load of spent fuel assemblies are arriving at the Vologne rail terminal, situated at 20 kilometers from Cherbourg. They're protected by a watertight steel package called a chateau or cask. It weighs 110 tons for 10 tons of spent fuel. This positive strong box is mainly designed to resist temperatures of more than 800 degrees Celsius and can be dropped from several dozens of meters. The road convoys between Valognes and the La Hague plant originate from one of the 58 French nuclear reactors, or reactors belonging to overseas electricity companies. One hour, 10 minutes after leaving the Valognes rail terminal, this unusual road convoy arrives at the La Hague plant entrance gates. In the receiving and dry unloading facility control room, engineers go about unloading a spent fuel assembly. This one assembly produces the energy equivalent of 27,500 tons of oil.
96% of the material contained in the cladding of this fuel can be recycled. 95% is uranium, 1% is plutonium, and only 4% is fission products or waste.
On the other side of these windows, which are 1.20 meters thick, the removal of the fuel rods from the assemblies is monitored from the control room. The assembly, still at a temperature of approximately 200 degrees, is cooled initially in water and checked prior to being placed in a basket. This basket will be set down in one of the 4 reprocessing site pools. This 500 kilo spent fuel assembly is carefully set down at a depth of 9 meters. It will stay in the pool, where it will continue its decay process prior to being treated. In the plant's control room, engineers carry out the actual treatment process by remote control. First of all, the fuel assemblies are sheared in accordance with an automatically controlled process. Only a few operating and maintenance operations require human intervention. These interventions are carried out by means of manipulators. Using remote manipulation, tools and materials can be handled by remote control, making it possible for the staff to operate under optimum safety conditions, as they are never in direct contact with radioactive material. In the shearing facility, the cladding containing the spent fuel is cut up into segments. These 3-centimeter segments fall into a tank of hot nitric acid. The nuclear material is dissolved in this solution. The pieces of cladding, called hulls, are removed so that they can be compacted. The nitric acid solution containing the dissolved nuclear material is automatically transferred from the control room to the chemical separation facilities. Uranium and plutonium are separated and purified. The plutonium is recycled in the Melox plant to manufacture new MOX fuel. This will feed nuclear power stations for further production of electricity. Uranium, on the other hand, is reused for manufacturing nuclear fuel or transformed into a stable oxide in order to build up a stock of energy materials. The final residue or waste is to be solidified here in accordance with an extremely safe procedure, vitrification. From the vitrification facility control room, the fission products are calcined and then incorporated in a glass matrix, trapping the radioactivity and preventing it from spreading. This mixture is then poured into stainless steel containers. The proven chemical stability of this borosilicate glass, which is used to immobilize the fission products, constitutes an international consensus concerning the qualities of this matrix. This solidification guarantees watertightness and stability for hundreds of thousands of years. Hulls and end pieces are compacted by means of a press with a 2,500-ton capacity. These materials from spent fuel shearing are compacted and their volume reduced to 1/5 of their size. The result? The treatment of 1 ton of spent fuel generates less than 0.4 cubic meters of final residue. Owing to the volume reduction, the surface area for final waste interim storage for 40 years of French nuclear electricity does not exceed that of a football pitch. This optimization also makes drumming safe and makes interim storage easier. Moreover, the use of standard containers makes the handling and transportation of residue easier.
The knowledge and technical know-how acquired here are internationally recognized.
French waste is temporarily stored on the Le Hague site. As for waste from overseas spent fuel, it is returned to its country of origin in accordance with French law. There are approximately 4 to 5 transportations of vitrified waste that leave Le Hague each year. The containers are subjected to a final quality check carried out by the specialists prior to being returned to the customers. On the other side of the world, in the north of Japan, a load of vitrified residue from spent Japanese fuel in Le Hague is arriving at Rokasho Miura. During this time, one of the roundsmen inspects a vitrified residue interim storage hall. Each circle on the ground corresponds to a pit holding 9 containers of vitrified products. Waste corresponding to approximately 5 years of activity by French nuclear electricity equipment is temporarily stored in the pits in this hall, under the roundsman's feet.
为台湾4座核电厂中均未设计可使用 MOX 燃料的反应炉，在处理后分离出的铀布原料对台湾并无用处。台电公司主张铀与布原料系有价物品，可寻找一个合适的卖点再卖出，并表示将于在处理过后残余废弃物回运我国前完成贩售事宜，应可确保该分离出之铀布燃料不再回运我国。但台电公司未承诺将于契约载明此一条件，加上20年后多数主事者皆已退休，恐于未来被敷衍塞责、便宜行事，花费高昂代价进行再处理，只为化解干式储存卡关，最后仍需将这些铀及布运回我国，完全丧失用过核燃料棒再处理对我国的意义。且台电公司未来可能合作的目标对象，法国 Areva 集团于2014年11月29日遭《纽约时报》报道其前途未明，股价暴跌，致使民间团体忧心其能否如实履约部分，故多持保留态度。台电更应借此事展开议约，寻求核废料处理最有利条件。铀布原料应由合作对象全数买断。因此，本会建议，以合作契约载明用过核子燃料经再处理后所取出的铀与布原料，将于签约时由合作对象以市价购买，即行卖断为最佳，当断则断。若以有价商品视之，届时可能需付费储存或赔付违约金形式，需委托法国暂存，反增添境外再处理计划的不利条件。用过核燃料最终处置计划时程表，台湾预计2055年完成用过核燃料最终处置厂之建造与运转试验，并同时完成运转执照之申请与取得之后，处置厂开始营运。合作契约提高储存年限40年以上。台电公司的境外再处理原先规划，用过核燃料将暂存合作国20年。考量我国设置最终处置厂预计2055年完成，因可以契约提高储存年限40年以上，将花费113亿高昂金额执行的境外再处理计划，视为我国另一中期境外储存策略，取代目前危险露天干式储存，降低我国储存核子燃料风险，提高付费处理价值。台电履行对我国付费进行核废料再处理之优势契约条件，将暂存合作国20年提高为40年，为我国创造寻找核废料最终处置厂址与建设安全储存硬体所需之宝贵时间。参与废弃物回国需减容减量1/4。为降低环保团体疑虑，建议该合作契约应载明用过核子燃料经境外再处理后，其剩余产物回运我国之体积重量不得超过原运量之1/4。核分裂产物之放射性物质活度贝克数不得超过运送前之1/20。推动专责机构及无人岛最终处置方案。 燃料数仅可使用5年，遗害造货达10万年。用过核燃料数高424公分，重318公斤。再处理过后残余废弃物不锈钢罐高140公分，容积180公升。加速无人岛最终处置场新建进度。用过核燃料在国外透过再处理，体积与材积变小，辐射活度减弱，低衰变热，核种毒性半衰期降低，玻璃固化规格统一。残余废弃物运回储存之工程使用面积、设施与设备可相对简化，有利于国内无人岛最终处置场新建计划的建设。届时若能于2055年如期完成无缝衔接，用过核燃料当可有效管理与营运，以捍卫台湾人民环境与土地安全永续。日本核废料最终处置计划。
核のゴミをどのように最終処分するのか。国の計画では地下300メートルより深くに埋めることになっています。地上に影響が及ばないようにするためです。使用済み核燃料を再処理すると出る廃液。わずかな時間で死に至るほどの極めて強い放射線を放ちます。この廃液をガラスと混ぜて固めたものがいわゆる核のゴミ。放射能が問題ないとされるレベルに下がるまで数万年かかります。国が想定する最終処分場です。核のゴミは張り巡らせたトンネルの下に埋めます。広さはおよそ10平方キロメートル。2020年頃までに出る4万本を埋める計画です。
我们今天核废料没有办法处理，怎么去使用这个核电厂？
燃料棒无解剧毒，用5年或10万年。